Hi, welcome to this lesson on number patterns, geometric sequences. We're going to be looking at solving a geometric sequence problem, question 4. So we're given the sequence 0, x, y, and so forth is an arithmetic sequence. And the sequence given by x, y, 12, and so on is a geometric sequence. They want us to find the values of x and y. So the given information that we need to list down is, first of all, we have an arithmetic sequence and we're given a geometric sequence. So first things first, the most important thing, let us write the general terms for each of these sequences. Arithmetic, it is Tn equals first term a plus the previous term n minus 1 times the common difference d, and n is a natural number. For the geometric sequence, we have t sub n equals the first term a times the common ratio r, which has an exponent on top of it, which is n minus 1. And that is when n is a natural number. All right. So if we can work out the general term for each sequence, then we might be able to find the values for x and y that satisfy both of these sequences. So the values of x and y that we find have to satisfy both the arithmetic sequence and the geometric sequence. Okay, it can't just satisfy one and then not the other, because these x and y values are the same in both sequences. So let's have a look at the first one, the arithmetic one. The sequence is as follows: 0, x, y, so forth. Now, the property of arithmetic sequences tell us that there's a common difference. So if I do t2 minus t1, that gives me x minus 0, which is just equal to x. And if I do t3 minus t2, I get y minus x. Okay, so these common differences must be the same. These are our little d values here. So therefore, by that property of common differences, this common difference x here must equal this common difference y minus x. But now I can move this minus x over to the left-hand side and therefore get y equals 2x. Because all I did was add x to this side here, and I'm just mirroring it around in terms of the equation. I'm writing y equals 2x instead of 2x equals y. It means the same thing. But I'm writing it like this because now we have an expression for y in terms of x. So how do I express y? Well, it's 2 times the variable x. So let's call this equation 1. For the geometric sequence, I have x, y, 12, and so on. So just with these first 3 terms, I know it's geometric sequence. So the common ratio, so t3 divided by t2 is 12 divided by y. That has to be the same as t2 divided by t1, which is y divided by x. So these must be equal because it's a geometric sequence. So if I cross multiply both sides by x here, I then get y equals 12 over y times x, right? Because if I multiply by x on the left, the x in the denominator will cancel. And then if I cross multiply both sides by the y to get rid of that denominator in the right-hand side, I'll get y times y, which is y squared, and that's equal to 12x. So this is our second equation. So we have a system of simultaneous equations. So how do we go from here? Well, let us substitute equation 1 into equation 2. And let's see what we get after doing this. So y squared, well, y is 2x. So that's 2x all squared equals 12x. Exponential laws will tell me to square the inside of every single term. So 2 squared is 4, and x squared is just x squared. That's equal to 12x. So now I'm solving a quadratic equation. I'm going to bring all the terms over to the left. I get 4x squared minus 12x equals 0. Here I can pull out a common factor of 4, because 4 goes into 4 once, 4 goes into 12 3 times. And I can pull a common factor of x out here. So therefore I get 4x into, well, to get 4x squared, I need to multiply by x. To get negative 12x, I need to multiply by negative 3 equals 0. Okay. Now we have it in the factorized form of two factors being equal to 0. So we use the 0 law from algebra. That means this factor must be 0 or this factor must be 0. So therefore 4x equals 0 or x minus 3 equals 0. So for here I divide both sides by 4 and I get x equals 0. And on this side I move the 3 across by adding and I get x equals 3. So those are the two potential x values. How do we get the associated y values? Well, I can substitute these x values now back into equation 1. So let's do that. So for the pair xy when x is equal to 0, so if I put x equals 0 here, it's going to be 2 times 0, so y is 0. Or if I put my xy pair to be 3, so I've used 0 and I'm going to do 3, well, 2 times 3 is 6. So when x is 3, my y value is 6. Okay, so we have two possible solutions for x and y. How do we know which one is correct? Well, we've got to take each pair now, substitute them back into both sequences, and see if they make sense. Okay, so in this scenario, let's do 0, 0 first. So I'm just going to do a bit of cleanup here on my side. So let's get the eraser. Okay, so what we're going to do now is just substitute those 2 points that we found. So for xy being 0, 0, we will put that in to both sequences. And we've got to see, if we put it into both sequences, do those sequences make sense? That's the important part we want to get here. Okay, so let's have a look. For the arithmetic sequence, it's 0, x, y. Okay, so if I put the pair 0, 0 here, this is going to be equivalent to 0, 0, 0, and so on. So this looks like a rather boring sequence. It's just a list of zeros. But this is an arithmetic sequence because the first term a is 0 and the common difference is 0 because you're not adding anything on. So that is an arithmetic sequence still, right? But it's just a rather boring one. So the term would be Tn equals a, which is 0, plus n minus 1 times d, which is 0. But 0 times anything is 0, so it's 0 plus 0, which is 0. So your Tn is just 0 all the time for all natural numbers n. That is still an arithmetic sequence. It's what we call a constant sequence of just zeros. Okay. What about the geometric sequence? If I put 0, 0, well, that's going to be x, y, 12, so on. That'll be equivalent to 0, 0, 12, and so on. Now, this cannot be a geometric sequence because if I multiply 0 by some constant ratio, I do get 0 here. This r could actually be any number. I could do 0 times 1, that's 0. 0 times 10, that's 0. But 0 times any constant ratio, how will I ever get 12 here? 0 times what number will give you 12? There is no such number because any number times 0 is 0. So therefore, when x is 0 and y is 0, this pair will not work. So we have to discard this as a solution. It doesn't mean that the other one will automatically work. We need to also check it. So when x is 3, y is 6. So let's have a look at this one. The arithmetic sequence becomes 0, x, y. So forth, that'll become 0, 3, 6, and so on. Now this is an arithmetic sequence, right? The first term a is 0, and the common difference here is 3, because I'm adding 3 to get to the next term, right? So the general term for this one would be a, which is 0, plus n minus 1 times the common difference 3. That'll just give you 3n minus 3 for all natural numbers. So that's definitely an arithmetic sequence. What about a geometric sequence? Well, it's going to be x, y, 12, and so on. But we know x and y, that's 3 and 6, and 12, and so on. Now this looks like it's a geometric sequence because 3 times 2 is 6, 6 times 2 is 12. So this also satisfies the geometric sequence. Therefore, we can conclude that the only valid solution is this ordered pair here, when x is 3 and y is 6. All right, so when you do find solutions and you end up with more than one, it is always imperative that you go back and check all the solutions that you found, because in quite a few instances, you will find that not all the solutions make sense in the given context. All right, we'll do more, and I'll see you in the next one.